we're going to go over Leetcode, invert binary tree question. Major tech companies like Microsoft, Google, Facebook are asking this question while they're conducting their technical interviews. I hope you'll find this video tutorial helpful for your technical interview preparation. Let's start with reading the question. The question is very simple. It says invert a binary tree. So we are given a binary tree and we need to create a mirror of the binary tree. Basically, we will draw a line from the middle and swap all the left child nodes with the right child nodes. So in this case, we will need to swap 7 and 2, and the subtrees under 7 and 2 are swapped as well. So for example, 6 and 9 goes to the left side and swapped as well. We are also swapping 6 and 9 here. 6 goes left and 9 goes left and 6 goes right, and 3 goes left and 1 goes right, and these subtrees are swapped as well. There is a trivia here. This problem was inspired by this original tweet by Max Howell. Google, 90% of our engineers use this software you wrote homebrew, but you cannot invert a binary tree on a whiteboard, so F off. So this is a true story. There are many great developers out there, but the interview is asking you to know computer science fundamentals rather than creating applications. So it will be a good idea to learn computer science fundamentals, and Leetcode is a great place for this. So let's go on the whiteboard. So this is the function. So we need to implement a recursive function here. They're using depth first search algorithm and post order traversal process. So what we need to do is we need to go through all the nodes, process them using we have a three-step process here. First we need to implement left, then right, then we swap left and right nodes. Roots, no. So we swap left and right nodes and return root. So let's do this and see. First we go to the root left and we find the leaf node, so we return. Then we go to the root right and we find a leaf node and we return again. We actually process the null values there as well, but they're null, so make no difference. And then now in the third step for this, we need to swap left and right. So we create a temp node and set it to root.left. Then swap root.left with root.right. Then set the root.right to temp. So this is how we swap a variable, a node, etc. So this is step 1, step 2, and this is our step 3. Sorry. So this part is our step 3. This is what we do here. So we swap these two nodes. So 1 becomes here, and 3 becomes here. So first step is done for this. Second and third step, so we can go back to the first node, root node, and implement the second step, which is root.right. This time we'll go right side and process that side. 7. Then we go left and process this. Then this is leaf node, so we return. Then we go right. This is a post order traversal. We process left, right, then root. Then this is leaf node as well, so we are returning. Now we did left, right, now we will swap the nodes. So 9 comes here, 6 comes here. So we swapped 9 and 6, and we did the third step here, so we can return. Now we are back to the root here. We did root left, we did root right. Now we need to swap these two pointers. So basically this will be pointing here, 2 will be pointing here, oops. 2 will be pointing here, and 7 will be pointing here. So all the subtrees are changing as well. So the new tree will look like 4, 7. So we are swapping 2. So 7 and 2 is swapped, and we already swapped these numbers, so they become 3, 1. Oops. And 6 and 9. And 9 and 6 have already swapped it as well. Let's see. 6 and 9, so we already 9 and 6. 9, 6. So when we create three nodes, when we link with the lines, I guess let's do that as well quickly. It's not the greatest drawing, but so I hope you can understand from this. So this is our new inverted tree. What we need to do is implement 3 steps on each of the nodes using depth first search traversal, going through all the nodes and going back to the root, doing the right, then go back to the root, swapping, then go back to the root, then implement right, then left and right, swapping, go back, swap left and right. That's all we need to do for this question. And this is how we invert a binary tree. So let's see this in the code. So first we check if root is null, then we return root. First we invert left, then invert right. Then we simply implement the third step and change right and left nodes. So let's submit and see if it's going to work. So bingo, it works. So this is pretty much it for this question, and I hope this helps you understand inverting a binary tree. I have more videos coming up, so if you subscribe to my channel, I'm sure we'll meet again soon. Thanks for watching. Goodbye.